Hello, I'm Wendy Chotton. I'm a medical geneticist, and I'm really pleased to be here today to talk to you about what we've been learning from Simon Searchlight about HIVE-P2. So let me first start by introducing Simon Searchlight. Simon Searchlight is completely free to you to participate, and it is a way of being able to share your information with the entire research community without anyone knowing who you are. It's a way of being able to contribute once and then having potentially dozens of researchers around the world be able to work for you, work on understanding HIVE-P2 and how they can support you and your family better. As we do this, we've been, by the way, doing this for about 10 years now. We've just had our 10th anniversary. And as we do this, we try and make it as easy as possible for individuals around the world to be able to participate. So we do this in many different languages. We do it with people being able to do things online, or in some cases, if they like, talking to a genetic counselor who knows about these conditions, and then to be able to, in some cases, also provide samples, be they for instance, blood samples are most common, but in some cases also other samples like saliva samples. As I said, I'm going to show you back some of the data that come from you. So we've organized it. Hopefully we've made it in a way that's more understandable, but it's your data. And so I wanted to make sure you had a chance to see what was going on. So here we go. This is what we've been learning about HIVE-P2. Let me show you some of the numbers so that you have a sense. I want, for those of you who are data driven in terms of understanding this, I want you to understand the numbers because there are some limitations in terms of what we know. I think the numbers are great, but they are still somewhat limited. So in terms of the number of people that we started this process with, 38 of you started the process of starting to sign up. And one of the first things that we do to make sure everyone's really in the right club is we look at your test report, your genetic test report. And so not everyone is able to put their finger on their genetic test report or come up with a copy and upload it into the system. And so not everyone has made it past this first critical step. I'll show you some of the data in terms of those genetic variants, but for me as a geneticist, it's very important that we do this step of quality control to make sure that those people that we're reporting back to you are people that are in the right club. That is, that they really are in the HIVE-P2 club, because I will tell you, it's been on more than one occasion where I've had someone that thought they were in the right club and they really weren't. And in some cases, I was able to help them get to the right club, get to the right diagnosis. And in some cases, we still may not know their diagnosis, but it is important to be able to follow the right guidance. So with that, getting beyond that first step, as I said, we have a team of genetic counselors. They work closely with me. They're really lovely ladies who speak on the telephone in some cases in many different languages. We've hired them particularly with that in mind, and also with a translator when they don't speak your language to collect this data. And speaking with them, many people find quite helpful because it's a conversation back and forth in terms of being able to clarify things or having you ask questions. In addition to that, we have the opportunity to fill out surveys online on the computer, again, in many different languages. Again, I want to underscore the numbers though. We're talking about somewhere between 26, 27, 28 of you. And so as I'll show you in a second, that represents many people, but it doesn't represent thousands yet. As I said, I expect that when we go back to an in-person family meeting, which by the way, 2022, get ready for next summer, we will be doing a lot more in terms of the collecting samples at those family meetings. And those become incredibly important, as you're going to hear from other segments in the Searchlight meeting, for researchers being able to work for you. That is getting cells from you, being able to model your child's brain in a dish and being able to understand that better. Ultimately, to be able to help people both in terms of developing new treatments and being able to understand how the brain is working. So within this is a summary of what we have in terms of those cell lines. I was alluding to blood samples. So this is whole blood. We can take a portion of those blood cells that are called lymphoblastoid cells, and we can make cell lines. So those continue to live in the laboratory, sort of on and on and on, so that we don't have to keep bugging you for samples. Researchers can use those to study your cells and your genetics. And then in some cases, we make what are called induced pluripotential stem cells. So this is something that the Simons Foundation has taken upon themselves, spending literally in some case hundreds of thousands of dollars in terms of the investment for your community. Each one of these is derived from a single person, and it allows us to be able to take what start out as blood cells and make them into something that looks like brain cells. And it allows us to do this without taking a biopsy of the brain. It allows us to do it from a blood cell, and then through some fancy methods to be able to make them into something that can be transformed into brain cells or liver cells or heart cells. But of course, we're interested in the brain, so researchers oftentimes make those into the brain cells. So this is a little bit of gobbledygook, but for some of you that are real aficionados, especially some of you as researchers, I wanted to put this information up here. This is looking at the genetic variants in HIVE-P2. I'm classifying these by different classes. So some of these we think destroy one of two of the HIVE-P2 copies. So one gene is always, one copy of the gene is always just like everyone else, but it's the other, the second copy, that has a difference. In some cases, these frame shift or nonsense changes, we think essentially destroy that second copy of the gene so that it's not functional. There are some other changes, and this is the majority. So if you look by numbers of lines here, the majority of individuals have these types of changes. And in some cases, the same genetic change. So for instance, at amino acid 943, where there's usually an arginine amino acid, instead for 4 individuals, it stops right there. So it's the protein is being made, and then boop, it stops at that point, and the rest of that protein isn't made. And we believe that this copy of the protein, or this copy of the message to make the protein, is actually dissolved. It's sort of not stable and doesn't last very long. Within this, I'll also point out this last column here, which is how we classify the genetic variants. Pathogenic is most common. That means we're certain this is associated with a HIVE-P2 condition. There's another category called likely pathogenic. In those cases, we're pretty sure, and pretty sure for us means about 90% sure, that this genetic variant causes a functional change in HIVE-P2. But you will notice, that there are a couple times we see a variant of uncertain significance, or a VUS. And in those cases, we're not actually 100% sure that it's changing the function of HIVE-P2. And again, or not again, but to show you, these are what we call missense variants largely. So these are single amino acid substitutions, one tiny change in the gene. And in fact, it's so tiny, we're not sure exactly what it means. For those individuals who are variants of uncertain significance, in the other data I'm going to be showing you about, I've actually taken them out. So I haven't, because I'm not certain about them and I didn't want to cause any confusion. The other data I'm going to show you throughout the talk is about individuals with pathogenic or likely pathogenic variants. Again, this is mostly for researchers, but just pictorially to see this on a stick figure of the HIVE-P2 gene, there are some important domains or important regions of the gene that I've shown here in terms of zinc fingers or nuclear localization signal. When you see the distribution of the variants throughout the gene, these are color-coded. Those frame shift or premature truncating mutations are shown here in the yellowish. Everything above the line is pathogenic or likely pathogenic, and everything below the line are those variants of uncertain significance. I will say that it's interesting that we see the same genetic change for some of these variants of uncertain significance, and we also see the same genetic change in some cases. This is what I was showing you on the slide before with the arginine 943. These individuals are not related. So this isn't like Ancestry.com where you find out that this is your distant, fourth degree relative, second cousin once removed. Most of these changes are de novo or new in the individual with the HIVE-P2 related condition. So if it's new for all of these individuals, they're by definition not related to each other. It started brand new with that person. It was not inherited. So that's the first bit of orientation in terms of what the genetics are. I want to now transition in talking about the medical conditions associated with this. So the next piece of information that's important for you to know is this is the age distribution of the 19 individuals I'm going to tell you about. So again, these are individuals with pathogenic or likely pathogenic variants. You'll see that most individuals are still relatively young, so below the age of 10 for the majority, a few that we have that are adolescents, and then we have this big gap. We don't have very many individuals who are young adults, although we do have exactly 2 people who are above the age of 40. So I will say there are certain limitations in what I'm going to say because we're mostly limited to individuals who are less than the age of 15 that I'm reporting to you. When we think about how this affects the body, it mostly affects what I call above the shoulder. So it mostly affects the brain and behavior overwhelmingly. So far, everything that we've seen, as I'll show you later, is that people continue to make forward steady progress, although there are delays in terms of how quickly they learn, and there are challenges in terms of how they behave, in large part because I think their brains are working differently, and there are things that can make them anxious or nervous because it's just hard for them to process as much information as other people do. So almost universally, we see individuals who have either developmental delay or intellectual disability. I think if we were to measure this quite precisely, it would really be 100% or close to 100%, but the vast majority of individuals do have those issues. Almost everyone also has issues with language in terms of being able to speak or learning how to speak. Not to say that people won't speak, but it is certainly delayed and there are problems with articulation or how clear the words sound. About a third of individuals have autism, and again, small numbers still, but there are some individuals who have attention deficit hyperactivity disorder or ADHD or problems with anxiety. Again, still some small numbers though. When we look at other, not necessarily behavioral problems, but ways that we can see that the brain is making the body work, again, we see a lot of those symptoms. So number one is low muscle tone is quite common, again, almost universal. Other problems with coordination, not the most fluid movements, people who look like they're clumsy or may trip more or have difficulty in terms of being coordinating either their movement in terms of walking or jumping or skipping, or even in speaking. And so this is a common issue in terms of putting all of those things together. This is somewhat related to, as I said, this movement disorder and much less frequent in a good way. Seizures are not common. So we only have one individual in this group who has had seizures. So I'm happy that that's not a common issue. There are some other medical issues, and the most common medical issues that we see are with vision. So the way the eyes are working, some problems about a lazy eye or strabismus, some problems in terms of needing glasses or being able to see far away. The reason I bring this up is because you need to have good data coming into the brain. So you need to be able to see clearly, you need to be able to hear clearly. And so really important in terms of these are in most cases addressable in terms of being able to have a good pediatric ophthalmologist that will be able to help correct these. So strong recommendation in terms of making sure all our young people have at least had an initial evaluation with the ophthalmologist or the eye doctor. Gastrointestinal issues also very common. 2/3 of individuals to the majority have problems with constipation, diarrhea, reflux or heartburn, sometimes food sensitivity, specific diets or specific parts of the diet that can be sensitive. Very common in terms of this. Sometimes they get better with age, sometimes they outgrow them, and sometimes they change. And they can go through phases in life where it's more diarrhea or more constipation, but this is very common. Endocrine problems, which we see in about 20%, are typically problems with growth. Individuals that may be shorter, maybe skinnier, having problems gain weight. It's not clear to us exactly whether this is something that's going to respond to something like growth hormone. I am, just to be clear, not saying to go out and try growth hormone on this, but we do see that these are problems with growth. And then again, minor things. But when we see numbers like onesies and twosies, I'm not going to take a lot of time explaining it because it's hard to know if that's just coincidence or if that's really a thing. And that's where numbers would help us. So a common question that folks ask me is, are there medications that seem to help? This is something that, again, numbers matter in terms of thinking about seizures. And, are seizures, if they're there, they oftentimes, in the majority of cases, do need medication. And so that's one of the things that's really important to have normal function, normal learning. So 2 different medications that folks have used, but again, it's just 2, but 2 medications are common: valproic acid, Lamictal, in terms of medications for seizures. And then again, these are, remember, some are young children, so they may not have all of these features, but for some who have had problems with either mood or problems with hyperactivity, some parents have found medications to be helpful. So let me give you, in the last section now, an update in terms of what I'm going to call a growth chart, but for development. And so we've had some really fabulous psychologists working behind the scenes, a whole team of them, to try and think about your data in a way that would be very practical and helpful. And so a lot of folks tell me they'd like to know what to expect. So again, in terms of the constraints, to show you, this x-axis here has individuals up to the age of 14. So limitations, again, in terms of how much data we have and how far they go. But the good news is that people, this is chronological age. So this is the age, the real age of people as they reported the information. And this is what's happening. These are different people. So just to be clear on this slide, each dot is a different person, but different people are different ages. And so to try and get some sense about, if you see someone on Facebook or you've heard about someone who has an older child, I know many of you are asking, well, are they walking? Are they talking? Are they toilet trained? Are they, able to feed themselves? All of those things we wanted to go through. So in terms of doing this, these dots, as I said, are how they're able to gain skills over time, initially starting by using single words, putting words together in a short sentence, for instance, or then even something as sophisticated as telling a short story. And so as you can see, people are making forward progress. The slope is always positive. They're gaining those skills. Takes a ton of time. And I understand that in terms of your therapist, your teachers, drilling and going over these over and over. But I guess my message is, don't give up, because progress is being made. We also think about, and for those of you who have filled this out, this is part of the Vineland. You may have remember answering a bazillion questions. So this is now in terms of thinking about everyday skills and being able to, sort of be a little bit more independent. And again, progress over time, making forward progress. Some people all of a sudden can make more progress than others. And so you see some variability amongst people who might be 7 years old, and that's okay. But I think the good news is that individuals, first starting to eat with their fingers, eventually eating with utensils, and then being able to do things like helping to get undressed and even to help getting dressed. And so again, I think these are things that, in terms of being very practical and focusing on those skills, don't give up. There's progress that's being made. Another important dimension is being able to interact with others, or social development. And so again, this is for what you reported in the Vineland, and thinking about ways of being able to interact with others, either through simple gestures, showing that they want to follow instructions to please others, and to help out, to be able to help in the kitchen or help in terms of tidying up. So to help with some of those simple tasks. So these things do continue to mature. The next area is in terms of just, we call it gross motor skills, but it's things like hopping, jumping, skipping, those things that take some time. Again, those are coordination issues, and sometimes, and it's doing it over and over again. And it's that muscle memory in terms of just being then eventually on autopilot. So this does take time. And I'll point out that in terms of walking independently, for this, you'll see a broad range of age, some being able to attain this milestone earlier, some later, and some not yet. And so again, to think about this, I guess my point is that there are a lot of additional ways for physical therapists to have adaptive equipment to be able to help with this, to be able to, I've seen some gyms, for instance, that are just incredible in terms of being able to even suspend kids, and being able to have a combination of braces and other things that help in terms of developing these skills. Beyond just walking, being able to, for instance, walk upstairs, hop or jump, and eventually even something that obviously requires more coordination, catching a large ball. So the last part that I'll wrap up with is behaviors. And so this is something that we've broken down based on the instruments into younger children, those who are 1.5 to 5 years of age. Now do be careful because this is only 7 individuals. So, I can't say that this is representative of every young person. And then on the scale here, there are areas based on literally asking these same questions on thousands of other people. We have cutoffs in terms of knowing how significant a problem is. And so I'm showing you here, this is an area where there would be significant concern. Beyond this line would be mild concerns. And so again, young people, but in young people, we're starting to see some issues in terms of attention issues, aggression issues, oppositional issues. Again, not necessarily a concern yet, except for attention in a few people, but I'll show you some older kids in just a second. Anxiety, depression in the range of not a concern. On the other hand, now the kids are getting a little bit older. So this is ages 6 to 18. Again, small numbers here though, but now we're starting to see just the barely beginnings of some concerns, mild concerns about aggression, maybe creeping up in terms of some of that oppositional behavior. And so one of the big gaps that we need to fill is understanding what our kiddos are like as they're aging up. And as especially, I'll say adolescence, a lot of things change. And so we need to understand how behaviors might change then. So just to wrap everything up, in terms of some of the things that parents were reporting to us, some issues in terms of being able to shift gears, shift activities, problems that parents have in terms of, in part, getting hurt because maybe they weren't so safe to be on their own with some of those motor issues. Again, these are young children, falling, tripping, not having that coordination. And then problem issues in terms of at least the perception of being disobedient, and not being able to follow instructions or intentionally not follow those instructions. For the older kids, it was again problems with attention, really needing a lot of attention, and problems in terms of really being stuck on something, having some obsessions. So overall, this is the last slide, just to say that there are some common problems in terms of development, vision, coordination, attention, and really sometimes having issues in terms of misbehavior. I don't think our kiddos are bad, so don't take this as me saying that your kids aren't just incredible and loving and challenged. They work so hard with their therapies all the time. But with this, sometimes I think it can be tough for them to correctly perceive what's going on. And because of that, sometimes things are harder for them. And so sometimes behaviors, sort of spill over. And I think we know that. So within this, I hope importantly that this has been helpful. We will make sure this is available to you and your providers afterwards. And please do give us feedback about whether or not parts of this would be helpful in a different way and where there are gaps that you think are important so that we can make sure to work with you to collect information in a way you'll find helpful.